Welcome back to the deep dive. Usually when we sit down to unpack a topic, we're looking at something that feels a bit, well, incremental.
Yeah, a slightly faster chip.
Exactly. A faster chip or, a slightly better algorithm, maybe a new productivity hack. But the document we have in front of us today, titled The Agentic Shift, it just, it feels different. It feels like we're looking at the schematics for a completely different kind of machine. We aren't really talking about chatbots anymore, are we?
No, absolutely not. And honestly, if you're still thinking about AI in terms of just typing in a prompt and getting a paragraph of text back,
Yeah.
you are missing the actual revolution that's happening right now. The source material we're unpacking today outlines a structural shift.
From talking to doing.
Yes, from software that talks to software that does.
Yeah.
We are moving away from the era of wait and respond
Hmm.
and entering the era of autonomous reasoning.
From talking to doing. That's the mission statement for this deep dive. We need to figure out exactly how we get there because it sounds great in theory, but the mechanics, they're complex.
Very complex.
And the document represents this shift with a stack of visuals, architectures, economic curves, hierarchies. I want to start with that first visual, the evolution chart, because it draws a hard line between what we have now and what's coming. It lists three distinct phases.
Right. And it's crucial to understand where we are right now to really grasp the hype. Phase one is where most of the world still lives. Passive chatbots.
This is the wait and respond mechanism. The slide is actually pretty harsh here. It lists no context awareness and zero autonomy.
It's harsh, but it's fair. Think about it. When you open a standard chat window, the AI is frozen until you poke it. It has no memory of your business goals, no awareness of the emails you sent yesterday, and crucially, it can't act.
It's just waiting for you to drive.
Exactly. It's a parlor trick. It generates text based on a probability distribution. That's it.
Then the chart moves up to phase two, rigid automation. This feels like the stuff businesses have been running on for a decade. The if-then logic. The diagram shows a flowchart here. Instruction, decision, execute. But there's a big red X next to a broken link.
That X represents brittle execution. Rigid automation is amazing as long as the world is perfect. If you have a script that says, go to this website, click the third button, and download the PDF, it works great until the website owner changes the button color or moves it 2 inches to the right.
And then the whole thing crashes.
Right. It has no brain. It can't adapt. It just follows a track. And if the track breaks, the train derails. That is phase two.
Which brings us to the main event, phase three. The visual here changes from a linear flowchart to a brain-in-a-box connected tools. This is the agentic shift.
This is the breakthrough. The core differentiator listed here is the reason, plan, act loop. This is what separates a script from an agent. A script follows instructions. An agent formulates a plan.
So if it hits an error,
If an agent tries to click that button we just talked about and it's not there, it doesn't just error out. It stops, looks at the page, reasons, oh, the button moved to the top menu, adjusts its strategy, and tries again. It has real-time adaptation.
that ability to reason about an error, that's a heady concept for a machine. It sounds almost human. So let's look under the hood. The next slide is titled The Mathematical Engine of Meaning, and it claims to explain how a machine can actually understand intent well enough to plan.
Yeah, this is where we have to get a little technical, but stick with me because it is fascinating. It starts with tokenization. The diagram shows a conveyor belt taking the phrase, the agent glitters, and just chopping it up.
But it's not just chopping it into words, right? It looks like it's breaking them into roots and suffixes.
Correct. It breaks text into discrete semantic units called tokens. It preserves grammatical meaning. But the real magic, the thing that allows for reasoning, is the next part, vectorization and attention. The visual shows a 3D graph, looks sort of like a star chart with dots floating in space.
And the distance between the dots represents contextual distance.
Exactly. Imagine a massive, multidimensional map of every concept in the universe. The system maps those tokens to coordinates. The example in the document is perfect. Take the word apple.
I mean, to a computer, Apple is just a string of letters. APPLE. It means nothing. It's just raw data.
Right. But in this vector space, the system looks at where that token is clustered. If apple is floating near words like pie, fruit, and tasty, the system calculates the mathematical proximity and understands the intent is food.
Oh, I see. But if it's clustered near revenue, stock, and quarterly, the other cluster on the graph, it knows we're talking about business.
Exactly. That is the attention mechanism at work. It's weighing the relevance of nearby words to disambiguate intent. It's not keyword matching. It is calculating the geometric relationship between ideas.
So that is how the machine understands what you want it to do before it even starts planning.
Yes, it turns your vague human language into precise mathematical coordinates.
Okay, so the math gives it understanding, but understanding is an action. I can understand a recipe, but that doesn't mean I baked the cake.
That's a great way to put it.
So the next diagram is the one I found most helpful for visualizing the doing part. It's the circular diagram titled Anatomy of an Agent. They call it the REACT framework.
REACT stands for reason plus act. This is the heartbeat of an autonomous agent.
It breaks it down into 4 quadrants. In the center, you have the brain, the LLM, but the brain is surrounded.
Right, because the brain is just the engine. Its job is to break goals into subtasks via chain of thought.
But a strategist is useless without the top quadrant, which is memory.
The slide mentions VectorDB for context and history.
This is a huge distinction from a chatbot. If you tell an agent to book a flight, it needs to remember that you prefer window seats and you have a loyalty number from a conversation you had, say, 3 weeks ago.
And it pulls that from the database.
Exactly. That state is retained in the vector database. It gives the agent continuity. It's not starting from scratch every time you hit enter.
And then at the bottom, we have the tools, the hands of the agent. The icon actually shows a Swiss Army knife.
Because that's what it is. The agent needs a browser to look up flights, a code interpreter to run calculations, or email access to send the confirmation. Those are the tools.
And the brain decides which tool to pull out of the knife. Yes. And wrapping it all together is the outer ring, the loop. Observe, reason, act, result.
And notice the result step.
That's the critical piece. It observes the environment, reasons about what to do, acts using a tool, and then crucially looks at the result. Did it work? If yes, move to the next step. If no, go back to reasoning. That loop is the definition of agency. It's a continuous iteration based on environmental feedback.
It's impressive, but I assume not all agents are created equal. We have a pyramid graphic next, the hierarchy of agent intelligence. It reminds me of Maslow's hierarchy, but, for robots.
That's a really good comparison, actually. At the very bottom, the wide base, we have simple reflex agents. If X, then Y. Basically thermostat logic.
So we can probably skip past that.
Yeah, we can skip that. Moving up, we get to model-based, which maintains an internal state, and then goal-based agents.
And goal-based is where it gets interesting, right?
Now we're getting somewhere. A goal-based agent simulates the future to achieve a binary target, like get me to the airport by 5 p.m. It simulates routes to make that happen. It either succeeds or it fails.
But above that, we have utility-based agents. That sounds a bit more nuanced.
It is. The slide says it maximizes happiness or efficiency score. It's not just get to the airport, it's get to the airport in the cheapest, most comfortable way possible.
It weighs trade-offs.
Exactly. It understands that getting there on time but costing $5,000 might be a success in binary terms, but failure in utility terms.
And at the very peak, glowing in red, is learning agents.
This is the frontier. These agents self-optimize via critic and rewards.
Yeah.
They don't just do the job you asked, they analyze how they did it.
So they reflect on their own process.
Right. They think, I booked the flight, but it took me 4 steps and I wasted tokens. Could I have done it in 2? They learn from experience.
That self-optimization is the scary part. It means they get better without us touching the code. Now, for these agents to work in a real business, they need data. They can't just be smart. They need to know my business. The next slide is context engineering, and it shows 2 funnels, RAG and MCP.
These 2 acronyms answer the 2 biggest problems in AI, hallucinations and isolation.
Let's start with RAG, Retrieval-Augmented Generation. The diagram shows documents pouring into a funnel called the context engine.
RA provides the what? It injects your relevant internal documents, your company policies, your specific data into the context window.
So it's reading my actual files.
Exactly. It solves hallucinations because the AI isn't guessing based on its training data. It anchors the reasoning in truth.
And on the right, we have MCP, Model Context Protocol. The diagram shows a plug icon connecting to a flight database and a CRM.
Right. So if ARA is the what, MPP is the how. MCP is becoming the universal driver standard that allows these models to plug into external servers.
Because without MCP, the brain is just stuck in a box.
It can think, but it can't reach out. With MCP, it can touch the Salesforce API or check a live flight status.
So the synthesis here is RAG gives the brain the files and MCP gives the brain the hands to interact with the outside world.
Precisely. You need both. A genius with no hands and no memory isn't a very good employee.
Speaking of employees, let's talk about org charts. One of the key insights in this document is the architecture of collaboration. The diagram shows a supervisor or router agent at the top, managing a bunch of other icons.
This is vital. One of the biggest mistakes people make right now is trying to create one God agent to do everything.
Like writing a massive prompt for research, coding, email, and strategy all at once.
Right. And it fails. It fails because the context gets muddy, the agent just gets confused. This diagram argues for specialization instead.
It looks like a typical corporate hierarchy. You have the supervisor, the boss.
Exactly. The supervisor's job isn't to do the work, it's to decompose the goal. You say, build me a website. The supervisor breaks that down. It assigns the research task to a research agent, the coding task to a coding agent, and the testing to a review agent.
And I see arrows flowing back up to the supervisor.
That's the aggregation of results. The research agent doesn't need to know how to code. It just needs to find the best design trends. By containing the context to specific domains, as the slide notes, you drastically reduce error rates. Specialization creates reliability.
Efficiency through specialization. It mimics a human team structure almost perfectly. So if I'm a listener thinking, okay, this sounds amazing, I want to build this, where do I start? The document offers an implementation strategy, the step framework.
And look at the shape of the graph on this slide. It's not a straight line from zero to hero. It's a winding path.
It starts at the bottom left in the green zone, labeled Start Here, and curves all the way up to the goal state at the top right.
We call this the step framework. STEP, the S stands for Start Small.
Meaning deploy in low-precision areas where 90% accuracy is okay.
Exactly. Do not let the AI run your payroll on day one. Let it summarize internal meeting notes.
Because if it misses a detail there, nobody gets fired.
Right. You have to prove the concept in a safe sandbox.
And that leads into the T-trust. You build buy-in by over-delivering on speed in those small tasks.
People need to see it working to trust it. If the meeting notes are ready 30 seconds after the call ends, people start to get it.
Then educate. The slide says, document processes before automating. This feels like the step everyone skips.
Oh, it is the #1 failure point. You cannot automate a mess. If you don't know how your team currently solves a problem step by step, if it's just tribal knowledge in someone's head, and the agent won't be able to do it either, you have to document the flow first. You have to teach the process.
And finally, P, pain points. Target high-frequency, structured tasks first.
That's how you get ROI. Don't automate the thing you do once a year. Automate the thing you do 10 times a day. That curve on the graph represents managing risk versus complexity. You only earn the right to the goal state after you've climbed the curve.
Now, suppose I'm ready to actually build the stack. The next slide presents a choice. Building the stack. Code versus no code. It's a slider image.
This is the build versus buy decision for the AI era. On the left, we have no code and low code. You see icons for things that look like drag-and-drop node builders.
It says speed and accessibility, ideal for prototyping.
Yeah. If you are a marketing manager and you want to build a simple agent to sort your emails, you use this. It's fast. You don't need a computer science degree.
There's a trade-off.
Always a trade-off.
The slider goes to the right, code-based or native. We see the Python logo here.
This offers control and complexity. If you are building that supervisor architecture we talked about earlier, or you need to manage memory very carefully so the agent doesn't hallucinate, you need code.
The slide mentions granular control over state and memory and flow engineering.
Flow engineering is the new skill set. It's not just writing code. It's designing the logic flow of how the agent actually thinks.
So the trade-off is clear. Ease of use versus customization. You really have to pick your spot on that slider.
Exactly.
Now, we've talked a lot about capability, but we absolutely have to talk about safety. Because if these things can act, they can act wrongly.
Yes, they can.
The next visual is a big stop sign labeled Operational Safety and Governance.
This is the gatekeeper. You cannot deploy autonomous agents without guardrails.
The diagram shows the input prompt going into agent processing, but it's surrounded by shields called guardrails.
Those guardrails are programmatic rules. For example, do not discuss political topics or do not execute a database command that deletes data.
So they filter the input and the output.
It's like a firewall for behavior.
Then, after the agent does its work, it hits the HITL stop sign. Human in the loop.
This is critical for sensitive actions. Let's say the agent drafts a refund email to a customer. The HIPL step means a human has to actually click approve before that email is sent.
The slide calls this graduated autonomy.
Yes. Agents earn independence. Maybe for the first 100 emails, a human reviews all of them. If the agent gets 99% right, maybe next week you only review every 10th email.
You graduate the agent as its reliability metrics improve.
Exactly. It's not an on-off switch. It's a dimmer switch.
That makes a lot of sense. Trust, but verify. Now, I want to land on the final slide because it's the one that really made me stop and think. It's titled The Future of Work, Economics of 2026.
This is the so what of the entire deep dive. Look at the graph. It plots revenue and output over time.
There's a dotted green line called the traditional model. It shows revenue correlating to headcount, meaning if you want to double your sales, you usually have to hire twice as many people.
Which has been the rule of business for a century. Line goes up, headcount goes up. But look at the orange area, the leverage gap.
The agentic model line shoots up. Revenue skyrockets, but the headcount line at the bottom stays completely flat.
This is the decoupling. In an agentic model, revenue is no longer tied to how many humans you have. It's tied to how good your agents are.
The slide uses the term the unicorn light.
Small teams, under 20 people, generating massive revenue. We're already seeing this with companies like Midjourney.
Right, a tiny team, but a massive global impact.
Because they are leveraging silicon, not just payroll.
And the role evolution point here notes a shift from doing the work to managing the agents.
That is the career advice for everyone listening. The value you bring isn't in writing the email or crunching the Excel sheet anymore. The value is in designing the agent that does it and then supervising that agent.
You become the conductor of the orchestra, not the violin player.
Beautifully said.
And the baseline prediction at the bottom is stark. By 2026, agentic workflows will be a competitive necessity, not a luxury.
It's not a nice to have. If your competitor has decoupled their revenue from their headcount and you haven't, you simply cannot compete on margin or speed. You will be obsolete.
That is a heavy thought to end on. We've gone from the simple, passive chatbot through the math of vectors, the anatomy of the React loop, the team structure of specialized agents, all the way to this unicorn-like future.
It's a complete structural shift. We're moving away from software as a tool, something you hold in your hand, to software as a teammate.
Software as a teammate. I love that framing.
And here is the provocative thought I want to leave everyone with. If we are moving toward a world where managing a team of silicon agents is more valuable than doing the manual tasks yourself, the question isn't whether AI will replace you.
What is the question then?
The question is, which part of your current workflow is ready to be handed over to an agent today? Because if you don't figure that out, someone else in your industry will.
And on that note, I'd encourage you to pull up the diagrams we discussed, specifically that step framework curve, and see exactly where you fit. Are you still at start small, or are you ready for the goal state? Thanks for breaking this down today.
Always a pleasure.
And thank you for listening. We'll see you on the next deep dive.